Hello, everybody. Good morning and welcome to OpenCV Weekly. I'm Dr. Satya Malik, CEO of OpenCV. Our guest this week is Oscar Onberg, ML Solutions Engineering Lead at SuperAnnotate. They are a leading data annotation platform and an early AI success. We'll be discussing a very serious problem today: bias in machine learning datasets. But first, with me, as always, is Phil Nelson, the Director of Content and Creative at OpenCV. Phil produces the show, and if ever anything goes wrong, it is his fault.
Except for that one was your fault. Good morning, everybody. It's a great day for anti-imperialists. If you know, you know. I'm Phil Nelson, the co-host with the co-most, the second banana who is second to none, your plus one and only, here to remind you of a couple things we do every single week here on OpenCV Weekly. The first of which is a special giveaway to you in the audience. Our guest has generously decided to donate some OpenCV or some SuperAnnotate credits for you in the audience. Later in the episode, I will ask a trivia question based on the presentation. The first person to answer that question will get some free SuperAnnotate credits, thanks to our guest today, Oscar. Also, we'll be taking Q&A from you in the audience, so use that Zoom Q&A button down at the bottom of the screen at any point in the webinar to ask your question. It's the best way to make sure that I'll see it and be able to ask it during the show. Or if you're watching us on Twitch or LinkedIn or Twitter or YouTube or wherever else, go ahead and ask your question in the chat there. I've got the chat up here, and I should be able to flow that into conversation as the things go on. Satya?
Great. So welcome, Oscar. The show is yours. Take it from here.
Thank you. Thank you, Satya. Thank you, Phil, for introducing me. Happy to be here. So, as Satya said, my name is Oscar. I'm leading the solution engineer team at SuperAnnotate. And today I'll be talking a little bit about dataset bias, basically, how to deal with it, what to think about it. And got a great introduction to SuperAnnotate from Satya as well. We work with machine learning datasets, creating them. And dataset bias is, of course, top of our mind in a lot of these cases. So how do we work with it? It's what we'll go through a little bit today and the general thoughts behind it. And first, just a small intro to what we do in general to SuperAnnotate and help with. So we work a lot with the cases of providing our users a platform, which we call our data operations platform, to both speed up the labeling process, get control over your annotation workflow, and spot quality issues in your data sets. Together with that, we also help our clients with the service part of the annotation pipeline, helping provide both a high quality outsourced workforce and managing that in general to give the high quality data sets needed. On top of that, we also have our MLOps success program, where we help with anything ML related that might be needed, and help you with the integration and any kind of extra thing needed. And all of this comes together in our unified annotation environment, where we have our platform for your pipelines and annotations, services to help with anything related to outsourcing, and our ML success, where we help with anything on the machine learning side of connecting it to your existing pipelines and make sure you have a thorough MLOps pipeline in place. That's shortly about us. So now what everyone came for today, I suppose, is what we're going to talk about today. So I would just like to cover a little bit about what bias is to start with. It's a term that wears many hats. There is a lot of things, so we'll define what we're going to talk about today. And then also just look into how you can measure bias in general, ways to reduce it. And one example of that could be working with consensus. And in the end, we'll wrap up and, as Phil said, take some questions, and I'm happy to chat about anything that might be.
I have a question about this. I have a question about this graphic because I love it. Was this stock art, or did somebody at SuperAnnotate make this?
It's internal to superannotate, so I'll
I love it.
have to shout out
Yeah,
any graphic designer for this.
big shout out.
Wonderful. So less nice graphics in the next slide, but still not too bad, I would say. So to start off, like, what is bias? There are a lot of meanings. So some of the examples could be we have the bias variance trade-off. People might have heard of from Intro to Machine Learning and the like. Have bias terms in neural networks. It's also something that might be covered in some cases. Those are kind of model specific, yeah.
I actually don't
Yeah,
like the
please.
word bias variance trade-off because at least in case of deep learning, I have actually written a post about it. But then after that, I started thinking that I also read some Twitter post somewhere that that the right wording for this bias variance trade-off, at least in deep learning context, should be underfitting and overfitting, right? Otherwise, it's very confusing for people to understand. Oh, what is bias variance? Then you have to explain what bias is, what is variance, etc. But if you say underfitting and overfitting, it's very obvious that your data has trained, but it is not fitting when it sees new data. And overfitting is when you are actually, the training is on the training data, it's doing very well, but on the test set, it is not doing very well. In case of underfitting, you're not doing well in either case, right? Both the training as well as the test set, you're not doing very well. But so that
Yeah,
that
totally
confuses
agree
the
there.
whole space, right?
Thoughts on that, Oscar?
Exactly. No, I agree there. It's very much like a much better term talking about underfitting and overfitting. And the bias variance trade-off, like, you hear it in all of the intro to machine learning courses and these kind of things, but it's honestly a confusing term. So bias comes in so many places, and I think confuses a lot of people because it has so many meanings and you talk about it in so many cases. So I think it's good to really go over this. And I think, Satya, your explanation there shows very well what it is more about, so to say. Totally agree there. So that's why we will not focus on those today. We'll instead focus on what we are good at superannotate. That's more the data set side. But even within data sets, like, there is a lot of things that can be termed as bias. We'll go into what I mean with these, as they might not be, specific terms that are commonplace, but you can have some data set sample bias, human sampling bias, and also introduce bias from humans in the annotation practice. And we'll focus specifically on the last part today, but I first want to just go over and cover the other ones as well, just to show a little bit of what we're not going to talk too much about. And we already covered a bit on the bias variance trade-off, so I think people might have understanding what that is about. And the better term might be underfitting versus overfitting when it comes to deep learning as well. So most people might be familiar with the top image there with some scatterings talking about low bias and high variance and these kind of things. So what we can think about, I would say, sort of connecting to Satya, what you talked about with overfitting and underfitting would be kind of the bottom slide, where we can see that we might have a simple linear model, but if our data is polynomial or some other higher dimension, we might not fit that well. So we will have some kind of underfitting. And we would then have some kind of constant bias term here. So right, the model will not really perform. So we would need to increase the complexity of our model, perhaps, to catch the more complex behavior without trying to overfit. If we think about it in pure, easier mathematical terms than the actual deep learning functions that be a bit more high dimensional than this.
Yeah. Can I add one more thing to this discussion? Because this is one of my favorite discussions in school. When you were in maybe high school or even in earlier than that, you may know that at least when I was growing up, we used to be assigned marks, right? Points. So it's not somebody who got, let's say, 90 is superior to somebody who got 89, right? It was not like, oh, grades like A, B, C, D. No, no, no. It was right down to, from a scale of 0 to 100. And so it used to get competitive, these exams. And one of the things you would notice is that there were certain kinds of students who got very good grades, but they don't understand things. They have memorized things, right? So they memorized whatever is given in the was told by the professor or the teacher. And if the questions are from that set, they can answer it very closely, very, very nicely. But if you actually change the question and you want them to generalize, right? You change the question, or you ask them to think a little bit more, then they used to fall apart, right? So that exactly what happens in deep learning also, right? If you actually use a model which has a big enough capacity to learn, it will memorize each and every example.
Yeah.
And it will, no matter what this black box does, right? It has memorized the training set. If you ask any question from the training set, it is going to answer it properly, right? And that is a classic case of overfitting. On the other hand, but the goal of machine learning is not to do well on the training set. The goal of machine learning is to do well on unseen data. So there is always this tug of war between, you want to make it work well on the training set, but you also want it to not memorize the data, right? So that you are doing well on unseen data. So that's the classic bias variance. That's another way of thinking about the classic bias variance trade-off, or underfitting and overfitting problem.
Yeah, for sure. I think, we talk about that a lot internally as well, in terms of having representative data sets that labeling and everything, it needs to be in the same sort of vein or area of what you would like to do later on. But of course, you're not going to be able to find the exact sample. So, yeah, it's a very interesting concept for sure. I think we'll come more to those things later on as well. It's definitely something I like to touch a bit upon, because it gets a lot into, on our part at least, like how you gather these data sets. So if we just check one of the last terms here, like this is something I think might be mentioned in some deep learning courses, like how do you define what is a bias term? But that's also absolutely not something we will talk about today. I'd rather focus on the other biases that are from data sets in general. And as we talked about, datasets, there can be bias introduced to these datasets from different things. And I think if you think about it in a more popular science approach, you often hear about biased datasets, and that's more of what I think of as the dataset sample bias. There are so many different forms, and for example, we have things that can be introduced, or what I call data samples that's bias, that can include biases in the data in and of itself, right? For example, if we're sampling a data set about humans and our society, we will inadvertently catch biases in our society that has been produced. So the data set will contain those biases, and it will propagate to our models as well. And
those are some of the most pernicious, because they're sort of baked into everything. I think we see this a lot currently, and in the history of AI, especially with all of the advancements in AI technology for sharpening images or taking better low light photos, where these algorithms are kind of racist, because cameras are kind of racist. They weren't designed to capture black skin well, and that's something that the AI community and the photography community really still need to deal with. And it's an example of what you're talking about now.
Exactly, and these biases can also be introduced in a sort of human sampling bias as well, in that the case of you actually choose a specific, because the other things could be inherent to the data itself, and other things can be introduced by doing some selections by the humans who are actually building the models. And that's something I think every CV engineer will always have to think about, like what are the biases, not only for the data I might have, but also how I build these cases. Like, as you mentioned, these things that can skew a data set or a model itself. And I think a real life example could be car safety, where men might have designed most car safety systems, and they did it with the assumption that a man was driving a car. So all crash dummies were designed from a male standpoint, and systems accordingly. So survival rate might be higher for men than women in crashes. And that kind of bias will be introduced by the engineers. And all of these are difficult questions, but worthwhile to keep in mind all the time.
Yeah.
Right, and some of I want to add something to it, that the cameras are not racist by design. I mean, they work better for lighter skin tone, and there's a reason for that. There's a technical reason for that. Not that they were designed for lighter skin tone, which could also be true, but most of the reason is that like I have a darker skin tone than Phil, but my skin would reflect lesser light for the camera to capture, right? That's just physics, right? So the details of my skin, if you let's say if you have an inexpensive camera, the details of my skin will be less reliably reproduced than Phil's bright skin, which is reflecting more light, right?
I'm a
So it
Dracula.
is.
It's true.
Right. So it's not just that the cameras were specifically designed, or the darker skin tones were ignored. It is just the limitation of physics in some cases. But in other cases, it's also that we'll build something. The test case, for example, it is possible that people did not just care about darker skinned people. That happens too. But I wanted to add
Right.
this nuance also, that sometimes it is not that people were completely inconsiderate. It is limitations of physics in this special camera case.
Definitely.
Exactly.
And
Definitely agree
this,
there.
there's stronger, probably the stronger bigotry there would have been in what technologies, proliferate, because what we're willing for them to be bad at. That's probably a more accurate description of the bias there. But continue, Oscar.
Yeah.
No, I think this is a great discussion, but I would also like to preface, like, we're not experts on any of these two areas either, though they concern data sets. That's
Right.
something our clients deal with a lot, and we try to keep it on their hand and help them as much as we can. But what we really try to help with is the last factor, the human annotation bias. And that would be the result of the human factor when doing annotation. So when people need to do the manual work of gathering labels for a data set and provide samples for the models in the end, there will be different interpretations of instructions, how to do the work itself, and that will cause some annotations to be made different with a same original data sample, for example. We'll introduce some bias. And outsourcing this work, scaling a workforce, that means handing over your work to another place and many more people. And this often increases the risk of causing differences in the dataset because we have more people doing it, but it's also a very necessary task for basically all supervised ML applications that we see right now in these domains. So it's something we need to think about, and yes, we should care about this. But why should we care? Well, we talked about this, that introduces bias, but why is bias bad? Well, if you have better data, we have a model, and we also need less data in the end. This is kind of the core of data-centric AI, and we're big proponents of that at SuperAnnotate, of course. But with less bias, the data becomes better, and you have a less biased data set. And these problems can cause large issues in performance, making the model behave in some ways you probably don't expect yourself to. If instructions or the end purpose is interpreted a bit differently, the model will just replicate what the dataset says. So it's worthwhile to keep in mind that you're creating the source code for your models in the end, and that has to be according to what you think would be the adequate result in the end. It's also quite difficult to change these afterwards because it basically entails redoing the whole work again and review the whole dataset. So yeah, it's definitely best to get it right the first time. So a lot of important parts here. We have gathering of data in different ways, annotating it, the modeling part with the overfitting, underfitting, but focus will be the annotation task itself today and how we can work with that kind of bias. So getting into this, like, how would we then measure bias and think about it? That's a really difficult question in terms of exactly what kind of a metric to use, because it would be different in different applications. And I think it's more important to think about what do we need to be able to measure it or find it. Because metrics will differ from use case to use case. The important thing would be more on the, say, infrastructure side to do a couple of things, like tracking activity on a user level would allow you to, first and foremost, measure these metrics you're looking into finding more things out about. So tracking that would be important, and you need some good format and a platform that supports it in general, of course, but with that in mind, we can find outliers. And then it's good to record a lot of things during this process and not just have the final label out in the end, but have an understanding of what is actually going on over time and how can we think about the actions that have been done during this process and how can we use that to measure bias. So just to show some examples of what you could look into to find out if there is some potential bias in the dataset or the annotation process. It's just like a sample slide right here, or a sample graph. Don't know if everyone can see, but basically this will show on the x-axis specific annotators, how they are doing. And on the y-axis, we see a percentage of their annotation that was placed for a specific class, just as a toy example. So in theory, right, this should be kind of smooth. Of course, this will not always be the case, but it should be able to show inconsistencies if we have a sufficiently large and randomly sampled data set. This should be kind of smooth along the annotator axis. And that's not the case right here, so this gives some indication, but I think that's what we need to think about in these cases. It will not give the full picture, we need more information, but it gives an indication on what might be an issue. We see, for example, that a couple of annotators have never placed this class. Is it because they never had those samples to begin with, or have they just ignored it in general? So we need more information, and this is just an indication. So I'll actually stop sharing this right now and go over quickly to our SuperAnnotate platform, just to show some ways that you can actually look into this a bit further. Because at this point, we might use this and other metrics we can talk about later to find out or get some indication that something might be wrong. But with unstructured data set like computer vision data sets, we would need to do some further investigation here. So what we have right here, this is from another webinar we've done earlier on the SuperAnnotate side on active learning, but it's a data set of grapes basically for object detection. And when it's been labeled both as an open source data set, but also by some people on our side just to show this example. So what we were able to do here is go into what we call our explore section to further investigate the data set, explore it a bit further. So if I've
What's your favorite kind of grape, Oscar?
So I would say this data set is possibly Syrah. That's one of the good grapes, I would say here.
Yeah.
Perhaps we can see some of those here as well. We'll see. Where are the Syrah grapes? Here they are. So this is basically what we can do here. We can try to filter and query our data set based on existing annotations or any prediction from a model as well.
Very cool.
But this enables us to dig into the data set. And we talked about having the infrastructure to be able to investigate this further. So what we can do here is also add other variables as well. So I actually saved a small query down here. This enables us to, for example, search all of the instances that have been created, in this case, all of the bounding boxes, created by certain emails. This is my colleague, Kevork, and we can right here see these are all of the bounding boxes that he has created. So if I might have found some issues earlier and seen that, I don't know about the class structure that he's placed or the distribution for this specific class, I might query that, investigate further. So now I'm getting a much more information, a better picture of what might be an issue. I can also include here more things. We can include and just take a look at the Syrah grapes, for example. And now we only see those made by Kev, and they are Syrah. So this enables us to dig into the dataset a bit more, and we can do further actions here to either add it to a specific subset, perhaps, if we want to investigate it further, put it in a specific training, or just change the status here to return it. So this specific item can, for example, be relabeled accordingly if we find some issue with it in general.
Wow, very cool. Very smooth. It's great to see how this, I've seen, we've been looking at Super Annotate off and on here on the webinar for over a year now. It's really cool to see how the platform's evolved and kind of you're sanding off the rough edges of this, pretty laborious task.
Right.
Oh, definitely. Yeah, this is absolutely something that we're really thinking a lot about and digging a lot into. And we have a couple of exciting announcements coming soon as well, related to diving even more into these metrics, interactive dashboards for everything, and having a real granular picture of this process in general. So that's what we really try to provide here. So with that in mind, that gives us a tool and an example for us to dive into the data sets and investigate them further. And with that in mind, we can take a look at other examples on how to measure these biases, for example. One of the potentials would be to just check a class correlation as well when it comes to either some true labels and what people placed to check their performance and see how they perform against each other. Here we have Rick and Jen, and there is an example here where we can see that Rick has a higher affinity of placing the car label, for example, when it should be bikes, while Jen is not that eager to do it. And this doesn't give us the truth, right? It doesn't say if anything is wrong or right, but it will give us a further indication of what we could look into. We can also look into other issues or potential things when it comes to the data. It could be if we do object detection, for example. What is the size of the bounding box the annotators are placing? We have a plot that shows each bounding box placed by annotator plotted by size, and also just a scale to see some kind of mean and so on. So here we can find some inconsistencies between people. If one places smaller bounding boxes in general, for example, that could be indicative of something that we might be able to look into. And then it's important to have this communication system to really further that and understand it in the process of creating this data set. So we can even run some statistical tests here as well, of course, and see if we can find outliers. But that's just about finding this out. And we talked about how to measure it, how to look into it further. We don't only want to be reactive, right? Like we want to be as proactive as we can as well. So there are some ways we think about how to reduce bias too, when it comes to having a good process in mind. And we touched upon it, but one of the things is to reduce ambiguity and the interpretability of the instructions and keep it very objective. So instructions of how to do a specific data set, how to create it, so to say, should be very detailed instructions. It should be as little as possible left to interpretation. And that will ensure that we have a very combined view of what is the right answer. We could also employ other techniques like multi-level QA. So that's sort of what this graphics down here shows, where we can have an initial annotator do the first round of annotation, place the labels, and pass it to another person who can review it as well. So we have two independent people reviewing the same data point, communicating between each other, providing feedback as well. It would be a continuous improvement here of further spreading that knowledge to the whole team. Because if one person has a certain bias, it might be that other people have it as well. So both through bias and general mistakes. And with a process like this, we can also have some subject matter experts in the end to quality check some of the data points or similar to kind of expand their capabilities as well in handling more data in general. So multi-level QA flow enables you to quality check a lot of data and make sure that there is according to certain instructions. Another way to do this, which we see quite a bit, is consensus. And it's a common tactic when it comes to reducing bias. And it can be good in many cases, like classification, for example. In some other cases, and to give a small background on consensus, in that case, it's basically we will have multiple people that independently will label the same data point, not knowing what the others are doing. And in the end, we can take some kind of consensus of their work to see what should be the actual true label or ground truth in the end. So this is usually reducing bias because we are averaging multiple people's output, but it will also increase work, of course. We have often 3 people or more working on the same labels, but definitely it's something that's worthwhile in many cases. Among that, consensus can both be used to, I would say, measure the bias among the annotators, not only as a final label acquisition strategy. But here is also an example where we can see the comparable consensus between different people to see how well they all agree with each other. So every annotator has been compared to the others, and we can see that, for example, on the red and black bars here, they have a score of 1 point, a score of 0, which means that on that specific point they did not agree with anyone else. And this can indicate, how well people are agreeing, and we can also use consensus to vote in the end or something, get the final label. But here it's more of a comparison example. Here's more consensus among people. Yeah.
I don't quite understand this picture. Could you explain if you go back to the picture? Yeah.
Absolutely. So this would be a representative example of basically checking different. I'm quite sure that in this specific use case, we're comparing images against each other. And I think one of the main confusing things is that not all people have done all images. So here would be, say, a classification task of some images. Mm-hmm. And the points we see would be image labeled by a specific person compared to the same image labeled by one or multiple of the other persons. If it has a score of 1, they are agreeing with all of the others. If it has a score of 0, they are not agreeing with anyone else. So some people have a score of 1, which means that they are agreeing on that point with everyone else, but not everyone has a score of 1, which of course doesn't really make sense here because if everyone should have it, everyone should have it. But the main thing from this thought is that not everyone has made all of the examples. It's more that we have.
What are those vertical rectangles?
So that would be the general spread of their consensus score in this case. So giving a box.
So the smaller the rectangle, so this is their own score. This is their own score with respect to others. So the smaller, it means that they are closer to the average.
Exactly, they're agreeing. Exactly, they're agreeing. And if they're smaller, they're agreeing a lot more with other people. If it's more spread out, they have a much wider difference. So the average there would, if it's a higher or lower average, would just mean in general how well they are performing in terms of agreeing with each other. But if it's lower, they are keeping that. I guess a low variance on that as well. They're keeping it more tightly, being more consistent in their work.
Okay.
So these kinds of examples can give insight into several of these metrics, like the variance or of the annotators, but also here the bias they might have compared to each other, so to say. So we would like to have people who agree a lot and are kind of consistent, and then we know we have a good team. So technically we would have sort of everyone on score 1, but with more or less objective cases, this will not be the case. And we'll come to the limitation of consensus, but it's also very difficult to measure in very many cases, like how you actually get the score itself.
Right.
But we also see it's being used in not necessarily the investigation stage of finding the right label, but also just in a way of how to get the ground truth. So an example could be to classify an image, and we have 3 people do it independently, and in the end we take the majority vote. So the final class would be the majority vote from these 3 people. And we see many different examples of how to do this. It needs to be a majority vote, it needs to be a total agreement, or something similar. And the issues here also scale with the more classes you might have, because if there is no majority, like if there is no consensus at all, how do you deal with that? Should it be then conferred by some experts to review it? It's good to have a custom process in place depending on the workflow that might be applied.
Right.
But as I said, like there are some limitations that we usually see. So I think consensus can be great for classification and other cases, not within necessarily computer vision, but also with problematic use, because finding out this agreement or score is not always the easiest when it comes to these cases, because you have way more things that needs to be measured and that comes into play. Like we have location, class, shape. There are a lot of metrics that we need to try to calculate and take into account.
Yeah.
So seeing the actual, calculating an actual score is more difficult in those cases, I would say. So from the superannotated side, we usually recommend multi-level QA as a better way to reduce bias and increase quality instead of consensus. All right. Great. So that's most of what I would have talking about today. So I think to wrap up really, and I guess some of the key takeaways would be that bias is unavoidable in these cases. We need to think about it that it exists in many different ways, in gathering, in models, in annotation. It is something that will be there, but it can be detected and we can reduce it in lots of different ways. So it's good to have good practices in place, good workflows to reduce it, and good practices to deal with it when it comes up. And to Superannotate, we try to implement it in all of the projects we do with clients and build our platform around that concept of reducing errors and bias when annotating data sets as well. So that's our goal, really. And that's all for me. Thank you so much.
Awesome. Thank you. Folks, where should people go to find out more information on SuperAnnotate, or if they want to follow you on social media or LinkedIn?
The best would be to go to superannotate.com, can easily get in contact with us there. Anyone with a SuperAnnotate email, it works well. We're all very much in contact with each other, so that's a way to reach me. Otherwise, it's oscar@superannotate.com. And very happy to talk and show our platform and talk about anything that people might be interested in. Just a friendly machine learning conversation is always appreciated as well.
Mm-hmm. Excellent. And you've also graciously, you'll be providing the prize for our trivia giveaway, which I'll be doing in just one moment. Would you like to tell the folks what they'll win if they answer the question correctly?
We're very happy to. Yeah, so we're giving away a team access for 7 people and 100,000 data points for our platform. So you'll be able to use our platform for these kind of exploration of data sets, labeling, anything else needed really for you and 7 other people that might be joining your team.
Awesome. Great value. Thanks for that. So I guess we'll do our trivia giveaway now. We might as well get it out of the way for those folks that are already here. So if you've never joined us before, or you just need a reminder, we're going to do a trivia giveaway now. I've chosen a question from the presentation, and the first person to answer the question correctly in the Zoom chat window, if you're not in Zoom, you can get there by going to opencv.live. We've got a few seconds still. The first person to answer that correctly will win what Oscar just described, a great value for anybody that's into machine learning, or if you just want to learn machine learning. So get ready to answer now in the Zoom chat window. If you have won in the last 2 months, please do not answer and give someone else a chance to win. Earlier in the presentation, we talked about how everybody on the panel here today disliked a specific term for a kind of bias, preferring over and underfitting to that term. What was the name of that term? Be specific. Be specific.
Or the phrase.
What kind of bias? What was that? Yeah. All right. I think, did Martin get it here? Satya, you see that? Yeah. Martin Lovell. Wow, you won. You were the first one in the Zoom chat, and
you're first.
You were the winner of our giveaway here. So congratulations, Martin Lovell. The answer is bias variance trade-off. And both Satya and Oscar agreed that over and underfitting were better terms for this type of bias. So Martin, please send one email to phil@opencv.org, and we will make sure that we will make sure that you get your super annotate credits. So congrats again. We're having some issues here. Speaking of which, operator, can we get the cat cam for a minute here? Yeah, there's our dear sweet friend, the as of yet unnamed cat. Tragically, our feline companion here in the set does not have a name. Those of you out there watching, within the sound of my voice, if you've got some good suggestions for what we should name this cat, please send them to newsletter@opencv.org, and we will read the best ones on the air, maybe next week, maybe later. Nobody's really quite hit the nail on the head yet. We've gotten some great suggestions, and we do read and appreciate all of them. So, please send some new ones in if you've got them. Satya, and we got something else. We got a lot going on within OpenCV land recently. Would you like to give a quick rundown for folks about the ongoing OpenCV AI competition 2022, which they've only got about less than 10 days to submit their proposals?
Yeah, so as every year, sometimes multiple times a year, we do OpenCV AI competition. And this year we have a competition which is divided into two tracks. We have the OpenCV Spatial AI competition, where there is a deadline coming soon. I think September 15th is the deadline.
Yeah.
Yes. Mm-hmm. And there you have to send a proposal how to improve the quality of depth estimation on Oak D Pro. And you could use all the available cameras. You could use neural depth inference. You could use anything you want to improve the quality of depth estimate from this camera. So that's the goal. The second track is OpenCV Core track, and it is pretty much an open. You can choose any problem of your choice and attack it. There is a deadline for it. It is later, in October. You have to submit by October. You have to submit a proposal. But I recommend that if you have an idea, start working on it right away. Send us the proposal so that we can send you some feedback on what will improve your chances of winning. And this track is actually, the lead on this track is OpenCV China. They are going to evaluate. The judges would be from OpenCV China. Will also help out, but they are taking a lead on this. And OpenCV AI, Spatial AI competition, that track is Luxonis is taking a lead on that track. So great. It's a great competition with at least $20,000 in prizes. It could be more, depending on how many people use the devices, etc. So please participate in that competition. It is a great way, especially for students who want to get their name out. It's a great way to participate in this competition and you can say that you have won this competition. And that would be great for your resume and others, hobbyists, people who are generally interested in these things, who are already doing things on the side. It's a great motivating thing that you have a deadline and you push yourself forward to win this competition. So please join the competition.
Yeah, sometimes constraints are the best thing for getting your creative and productive juices flowing. And so 25 teams will be chosen for the spatial AI track that Luxonis is sort of taking lead on there. And you've got until September 15 to describe how you will improve, how you intend to improve the depth estimation on the Oak D Pro, which Oak D Pro, for those of you who don't know, is the first Oak camera that has actual lasers in it. It does a structured light pattern in assistance of the stereo depth cameras and the 4K color camera. So it's a really beefed up, much more capable system, and we hope to see some huge improvements, even though the depth is already quite good. So good luck to everybody participating in that, and you've got till September 15 at 11:59 p.m. UTC -8 to get your proposals in for that. And with the OpenCV general side of track of the competition, this is much more like the ones we've done in the past. And as Satya said, it's a really a great way to get your feet wet in doing a project for computer vision. If you've never really finished something or never really started something but really want to get started in this exciting and rapidly evolving industry, it's a great way to do it by submitting something to the competition. And also it's really important to update the people out there with what you're working on, because it's inspiring to your fellow competitors, but it also, you're kind of leaving a trail of accomplishments for yourself to look back on later. And those things are really important. And they also look great on your resume and can help you in your career, get a job or start something of your own. We've got a few of our competition winners in the past are at Intel or Microsoft, or have started their own businesses, like Bart, who should be our guest next week. If we may have to shuffle things around, but next week our guest is supposed to be Bart, who created that incredible virtual reality laser tag type system, and they're actually installing it and putting it in places. And a big reason that's been successful is because of OpenCV Spatial AI contest last year. So, it'll be really interesting to hear what he has to say as, how things have gone since then. So those of you also, importantly, this contest is fully localized in Chinese for the first time. It's awesome. I think it's awesome to, hopefully next time we'll have more full localizations, but it's a lot of content to do well. And so thanks to OpenCV China for taking care of that as well on this one. And, good luck to all of our Chinese participants out there, Chinese speaking participants. So we've got a bunch of questions here. If you've got any more out there, please send them to us via Zoom or in the chat of wherever you're watching us. We're going to start with a couple here on Zoom. So Scott would like to know, do you find that some applications that benefit from highly specialized models, overfitting can actually be beneficial maybe in these ways? Have you found that to be true? We'll start with Oscar.
I think that's definitely, one of the cases. Yeah, absolutely. I think that can be worthwhile to think about, especially in cases of, say, surveillance cameras and these scenarios where, we want to deploy a machine learning model to a specific location or a specific scenario, and we can't really work, feature-based on these machine learning or deep learning applications. We have to work with the data. So I had cases where companies might set up a camera somewhere, but it doesn't really work out for that specific location for some reason that is unknown. It could say that the share is a specific say share is a human all of the time. So it really destroys the model. So you have to find data or that specific generally train model to kind of overfit it for that specific location. So have a specific model for each location that has worked very well for some of our clients in those spaces. Yeah. So there I see a purpose of kind of overfitting models on purpose for sure.
Satya, your thoughts?
Yeah, so there's another example, very not exactly the same, but similar. In fact, Gary Bradsky, who is the founder of OpenCV, he had a company and they were serving the movie industry, in which case the camera setup was for a very specific set. So the whole set would be green screened. And this, all the cameras there would be bolted, right? So this is a very specific set, nothing changes. And in that case, overfitting is the right thing because nothing changes. You just want to make sure that your system is robust to vibrations and things like that. So in those cases, the system was very much overfit for that particular set. And it would fall apart if you go and try it on a different set. If you do that, you just have to fine tune it and things like that. But overfitting does make sense when you have constraints that don't change, right? Like it's like lookup table, right? If you think about it, if you do want to do things fast, right, you can memorize things. Even it's a very popular technique in computer science that any kind of computation, if it is small enough that you can look up, then implement it as a lookup table. Yeah.
Yes, it's cheaper to just look it up than to redo the math or
Yeah.
or whatnot, right?
Yeah.
That totally makes sense.
Yeah.
Um,
And
on Twitch,
there is another nerfs,
oh,
for
go ahead.
example. You can also think nerf is, look it up if you don't know what nerf is, NERF. They basically try to encode a scene using neural networks. So that you take several pictures of the scene using different cameras, and then you can look at that scene from any angle. It's basically a kind of interpolation if you think about it. It's a kind of view interpolation that you can do on the scene. But that encoding is also, it is overtrained on that scene. It won't work on anything else. It is an encoding of that particular scene. And you can think about it as overfitting to that scene.
That makes sense to me. So over on Twitch, a user would like to know, what are some of the biases you've seen? So there's a lot of popular, well-known data sets that people use sort of generally. For example, COCO, we've talked a lot about on this show. What are some of the biases that are known in the COCO data set? Are there any that stand out to you? I know, Satya, and before we talked about, I think dogs are overrepresented in COCO.
In ImageNet, dogs are overrepresented, and that was actually on purpose. Because they also wanted to use the same data set for fine-grained image classification, where things are very similar to each other, and you still want to classify them. So I think that is the reason why they had different breeds.
So maybe like
of dogs.
different breeds of dogs. Yeah.
Yes.
Okay.
Different
makes
breeds
sense.
of dogs. So, but yeah, that's a popular bias. If you look at celebrity data set, obviously it's biased towards people who look better than
average.
Better than the average, right? So yeah,
Sure.
So there are very common biases like that.
Thoughts on this, Oscar? Any interesting tales of a data set bias in the larger data sets that you're familiar with?
I think it's more than not kind of clear in natural language processing cases, because interpretation of different text or sentences is, I think that it is usually more interpretation there than in some image cases. Yeah, there's I think too many specifics to tell, but yeah, there's a lot there. Also depending on what's your language background, what kind of things have you read before, like where did you study? These kind of things, play a role into this as well, and it's not always easy to catch. We usually see that someone who is a subject matter expert, who has been looking into a specific subject, it's very obvious to just say, let's label ABC. But when a layperson takes a look at it, it can be very confusing and not that clear at all. And yes, it usually have to be a lot of creative definitions along the way to ensure that everyone is on the same page.
Yeah, it makes sense, and it's been the basis of the show here. So, another attendee here would like to know, SuperAnnotate, are you hiring machine learning engineers right now at SuperAnnotate?
So we're not hiring machine learning engineers per se, but there's an open position in my team for a solution engineer position. So working a lot with our clients on the technical side and finding solutions. So I would encourage anyone interested in a technical but also customer-facing role to look into that. We're on LinkedIn and on our website.
Awesome. Yeah. Yeah. I mean, so we've got a couple more questions here. Let's see. Babak would like to know about data augmentation and how it can help combat biases once they've been found, perhaps. Do you have any thoughts about that, Satya?
Data augmentation can definitely help in certain kinds of biases once we have, especially when we have underrepresented classes, and if we are able to actually create data through augmentation for those classes or for those conditions, then yes, we can solve it. One easy example I can think about is that you may be able to do. This is a different kind of bias, and it's almost inconsequential, right? If your network is working very well in good lighting condition, then it's very easy to create a data set through augmentation where bad lighting conditions are simulated, noise is simulated, and all those things, right? So, but that's almost taken care of. Most people already do that through data augmentation. The difficult ones are the ones which are very difficult to get rid of. For example, let's say you have only lighter skinned tone people in your data set. It's not like you can just change the skin tone of people in that data set through augmentation and get dark skinned people, right? Because it's not just the skin tone, it's the person's face depends on their
Yeah, a
racial
lot of things will
background,
be
etc.
different.
Yeah, a lot of things. So it's not possible to solve that kind of bias through augmentation alone. And most of the things that can be solved through augmentation are already being solved through augmentation.
Thoughts, Oscar?
No, I think that's true, and it's worthwhile to be kind of careful sometimes when doing augmentation and think about how it's done, because it can also increase bias. Because if you already have a base data set that includes some biases in how the annotations were made or something else, augmenting that, which is to amplify the bias already have, it can be worth to think about it. And also what type of data you have. There was a competition last year from data-centric AI. So the twist on the feminist data set, I suppose, with Roman numerals. So if you think about that kind of augmentation, if you have now it's a 4, if you switch it around, it will be a 6 instead, then the augmentation will be
funny.
So I think it's you need to think about it a bit and not just apply it blindly.
Yeah, thanks for that. Ken has a comment here in the chat, says that for another example of bias in data sets, apparently DALL-E 2, the very well-known generative image generation system, mostly picks pictures of chemists when you ask it to show you photos of scientists. That's pretty interesting as well. We're buttoned up right against 10 o'clock here. Satya, you want to take us home?
Yeah, thank you everybody for watching this show every week. We really appreciate it. It keeps us motivated, and we'll keep bringing these interesting topics to you every week. So please show up, and it encourages us. And Phil, thank you for your contribution. It is always great to have a smooth running show. Also want to thank Oscar for this really nicely done presentation. And I'm very curious to check out Super Annotate again. I've worked with it before in the past, but looks like you guys have added a ton of new features which help exploring the data really easy. So I'm really excited to go and check it out also. That's it from our side. Shout out to our studio provider, Lightwist, who are doing such an amazing job. Every time this studio is getting improved, and the resolution is improving, the audio quality is improving. We are very, very thankful for their contribution to this as well.
Yeah, shout out to Yana, who's our operator today. If the camera moves were nice and made sense, it's all Yana's fault. Thanks, Yana. Next week, our guest will be Bart, probably, who will show us the next evolution of his awesome virtual reality laser tag system. It's actually, they're taking a fitness vibe with it. It's really fascinating. I encourage you to go check it out on LinkedIn. I think it's called REK, R-E-K. So our friends at Hackster are running a virtual event in October, the Hackster Impact Summit, October 11 and 12. Check that out at hackster.io. Shout out to our friends at Hackster. Hi, Alex and Jessica. We'll be here next Thursday, same bat time, same bat channel, 9 a.m. Pacific
I have one
time.
last little thing to add. Learn OpenCV. This is my personal blog. We are giving away one NVIDIA 3080 Ti for people who register for NVIDIA GTC through our link. So go to learnopencv.com and you can register and get a chance to win an NVIDIA 3080 Ti. That's the last announcement.
That's a heck of a prize.
Yeah.
Since we're doing personal plugs, for those of you that don't know, I do another show with the CEO of Light-Twist, Vikas Reddy. It's called The Light-Twist Show. You can find it on YouTube, LinkedIn, etc. Most of the same places you can find this show. That show, our guest next week will be Will Smith, not that Will Smith, formerly of Tested.com, and the Foo Show, and now runs the FossPod podcast, awesome open source podcast. If you haven't checked it out, you absolutely should. Anyway, we'll catch you next week. Operator, can we get that sweet, sweet outro? Thank you. Yeah, thanks, Oscar. This was a lot of fun. You nailed the timing here. I love your. I feel like you're always on point with the timing of the presentation. You're one of the guys I can always count on to not go over. Everybody else tends to talk a bit too much, but I guess that's the pot calling the kettle black from me. All right, we'll see y'all next week. Take care, folks. Thank you.
Thanks so much for watching this episode of the webinar. Please hit that like button, subscribe, and don't forget to tap the little bell icon to be notified when new episodes drop. This week's episode was brought to you by OpenCV Courses. Learn computer vision and AI from the best at opencv.org/courses. If you'd like to be in the audience next week, subscribe to the OpenCV newsletter.